All right, so I think we're recording. Let's take a look here. They're asking us to solve these two quadratic equations, but they are saying that we must solve it by a technique that's referred to as completing the square, which means I can't try to factor it. I can't use the quadratic formula. I have to use completing the square. All right, in completing the square, we need that leading coefficient to be a 1. So I'm going to start out by dividing every one of these terms by 4. So 4 divided by 4 is 1. So I get what I wanted. And now here I'm just going to write it as 9 divided by 4 and 9 divided by 4. So now I need this C to be a specific value. Half of this, half of B quantity squared. So, and right now it's not. So I'm going to add uh, 9/4 to each side of this equation. And I'm going to give myself some room here to figure out what value of C I want right here. And that value of C is to always take half of this middle term, and maybe in this case, since this is a fraction, rather than writing it as divided by 2, I'll write it as 1/2 times B quantity squared. What is that? Well, let's take 1/2 times -9/4 and square that. Okay, so that we multiply the two numerators together and get -9. We multiply the denominators together and get 8. And if we square this, it becomes positive and we get 81/64. And that's what we add to both sides of this equation. And now, as ugly as this looks, it's actually pretty easy to factor this left-hand side because it's a perfect square. We've got x minus 1/2 times 9/4 was 9/8. Now over here, I'm going to need to get a common denominator, so I'm going to take this 9/4 and multiply it by the number 1, but I'm going to be clever in how I write the number 1 and multiply it by 16/16. That will get me a denominator of 64. So on the left-hand side, I have x minus 9/8 quantity squared. And over here, I have a common denominator of 64. And so then I have 9 times 16, which is 144, plus 81, which is 225. When I do that, I have figured out sometimes how to twist it back, but I don't understand why I did it in the first place. All right, so what did I say, 225? Now that we have a perfect square, we can take the square root of each side. And I've mentioned in a previous video my thoughts about explaining to you why that when you take the square root, that you have to introduce a plus or minus symbol. It's not because of this number, it's because you have a variable on the left-hand side. And actually, technically, it's introduced in this next step. Now, I don't care, if somebody did put it in there at that step, I sometimes do it, but technically, it's down here. Now, when you take the square root of a product or a quotient, you can take the square roots individually. You can take the square root to the numerator 225, which is 15, and you can take the square root of 64, which is 8, and so now, hey, look over here, we have a common denominator. We have a denominator of 8, so we have a common denominator. So it's going to be very easy for us to get x by itself. We add 9 over 8 to each side. So we can give our final answer here pretty easily. Well, no, not our. We can give our solution set. Our answer is to illustrate every step here. The whole idea to this problem was to find this solution set in a way that was different from factoring and different from this quadratic formula. So if we have 9 over 8 minus 15 over 8, 9 minus 15 is a negative 6 over 8. We can reduce that here in just a second. If we add 9 and 15, we get 24 over 8. So both of these are even numbers, and this reduces to negative 3/4. And 24 is divisible by 8, and that reduces to 3. So this is our solution set, but remember that the directions had said completing the square. That's where your points are going to accumulate for this problem, not your final answer. I mean, it's how you got that final answer. All right, so now let's take a look here at number 17. And again, even though it's in standard form, that leading coefficient is not a 1. So we need to divide everybody by 3. So I'll have 1x squared plus 16 over 3x minus 10, because 30 divided by 3 is 10. Well, that's not the c that I want in order for this left-hand side to be a perfect square. So I get that negative 10 out of the way by adding it to both sides. 0 plus 10 is 10. Well, now I need to figure out what value of c will allow me to factor this left-hand side into a perfect square. We know that we want to take 1/2 times b and then square it. And our b is 16 over 3. And half of 16 over 3, well, is 16 over 6, but that reduces to, because the 2 to 8 over 3 squared, which is 64 over 9. So, oops. So that's what I want to add to both sides of this equation. And as ugly as that looks, this c was specifically designed to make it very easy for us to factor this left-hand side. All we have to do is write x plus, well, 1/2 of 16 over 3 was 8 over 3. And this is equal to 64 over 9. Now, since that's a perfect square, we can take the square root of each side. So if I take the square root of the left-hand side to balance the equation, I have to take the square root of the right-hand side. Because we're taking the square root of a variable, even though we just write this as x plus 8 over 3, I've explained in previous videos and in class why we have to put a plus or minus symbol there. It's actually coming from the left-hand side that this radical symbol means the principal square root, but yet to satisfy this equation, remember that the definition of the square root of x squared is the absolute value of x. So here I can take the square root of 64, which is 8, take the square root of 9, which is 3, and so if we subtract negative 8 over 3. What do we have? Well, if we subtract these two values, they have a common denominator, and so negative 8 minus 8 is a negative 16 over 3. If we add these two, they have a common denominator 3, but negative 8 plus a positive 8 is 0, and 0 divided by 3 is just 0. So our solution set is negative 16 over 3 and 0. But in this problem, I'm more interested in how you got that answer. You have to show every step, and every step has to be clear, and it has to be clear that you understand this technique of completing the square. So hey, I hope that helps, and I'll talk to you later. Bye.